Deep within the Himalayas lies the Yarlung Tsangpo Grand Canyon, the deepest canyon on Earth. Here, the river drops 2,000 meters in elevation over a 50-kilometer stretch known as the Great Bend. In July 2025, the construction of the world's largest mega project officially began.
This is the Medog hydropower station, a project estimated to cost over $167 billion.
The goal is unprecedented: to generate 300 billion kilowatt-hours of clean energy annually. Before any dams or tunnels can be built, extensive road networks must first be carved into the mountains.
Medog County was once one of the most remote places in China, making logistics the first major hurdle. Thousands of tons of steel, concrete, and heavy machinery are transported daily to the site.
The project is managed by the China Yajiang Group and Power China, aiming for completion by 2033.
Unlike traditional reservoir dams, Medog is a massive run-of-the-river project.
Instead of stopping the river entirely, engineers must build 4 massive 20-kilometer diversion tunnels.
These tunnels will slice directly through the heart of the Namcha Barwa mountain. To achieve this, some of the largest tunnel boring machines in the world are assembled on site.
Assembling these mechanical giants takes weeks of precision engineering. Once operational, the TBMs will grind through solid bedrock day and night.
But drilling through the Himalayas is fraught with extreme danger.
The region is seismically active, and underground geothermal temperatures can reach blistering heights.
Workers must constantly cool the environment to survive the extreme subterranean heat.
They also face the constant threat of rock bursts, violent explosions of rock caused by immense geological pressure. To secure the tunnels, thick steel arches and heavy concrete reinforcements are immediately installed.
Shotcrete is sprayed over the rock face to lock the loose stones in place.
Millions of tons of excavated rock are transported out of the mountain continuously.
This material isn't wasted. It is crushed further and recycled into aggregate for concrete.
Gigantic concrete batching plants are built on site to feed the project's massive appetite.
A relentless convoy of mixer trucks ensures a continuous pour for the structural foundations.
While the tunnels are drilled, work begins on the exterior diversion structures.
These structures will eventually guide the ferocious Yarlung Tsangpo River into the mountain tunnels. The structural integrity must be flawless to withstand the immense force of the water.
Piece by piece, the banks of the Great Bend are reinforced.
Every millimeter is tracked using advanced digital surveying tools.
Months of drilling culminate in the first successful tunnel breakthrough.
The first 20-kilometer passage is clear, but 3 more must be completed.
Air circulation systems are critical to keep the deep subterranean air breathable.
The rough rock walls are smoothed over with reinforced concrete to reduce water friction.
This will allow the diverted water to flow at maximum velocity toward the turbines. Above ground, the steep, narrow topography makes traditional transport impossible in certain zones.
Helicopters and massive cable cranes are used to drop heavy components into the valley.
The Medog project isn't just one station. It is a cascade of 5 separate power stations. This cascading design maximizes the energy captured from the 2,000-meter altitude drop. Deep pilings are driven into the bedrock to ensure stability in this earthquake-prone region.
The powerhouse for the first cascade station begins to rise from the valley floor.
Continuous concrete pours last for days to create a seamless, indestructible base.
Quality control is rigorous. A single structural failure here would be catastrophic. Next comes the installation of the penstocks, the giant pipes that will feed water to the turbines. These steel arteries must withstand unimaginable water pressure.
Every single weld is X-rayed and ultrasonically tested for imperfections.
Gravity will force the river down these tubes at terrifying speeds.
At the bottom of the penstocks lie the beating hearts of the project, the hydroelectric turbines.
These turbines are engineered to generate power on an unprecedented scale. Transporting the ultra-heavy generator components requires specially built transport vehicles. Navigating the Himalayan terrain with hundreds of tons of delicate machinery is an engineering feat itself.
The rotor is lowered into the stator with a clearance margin of just millimeters. Miles of heavy copper wiring will carry the generated electricity out of the valley.
Step-up transformers are installed to convert the power for long-distance transmission. Transmission lines are strung across the treacherous peaks, connecting Tibet's power to the mainland.
This grid will eventually power the AI era, supporting millions of homes and massive data centers. With the tunnels and the first powerhouse complete, the critical diversion phase approaches. To route the water into the tunnels, a temporary cofferdam must be built across the river. Tons of earth and rock are pushed into the current to choke off the natural river flow.
The mighty Yarlung Tsangpo fights back, challenging the engineer's barrier.
Operators work around the clock to seal the cofferdam before the river breaches it. Slowly, the river's path is altered, flowing seamlessly into the man-made caverns. For the first time in millennia, a section of the Great Bend runs dry.
This exposes the riverbed, allowing construction of the intake structures to begin safely.
All sediment must be cleared away to anchor the concrete directly to the Earth's crust. Geologists must ensure the bedrock has no hidden fault lines.
Formwork is erected to cast the permanent intake structures. To meet the 2033 deadline, construction does not stop for nightfall.
Massive steel floodgates are fabricated to control the water flow.
These gates will act as the master valves for the entire Medog project. The winch systems must be capable of lifting the gates against the immense friction of the water. With the intake structure completed, the river can finally be reintroduced. The temporary barriers are removed, allowing the river to flood the new concrete channels.
The Yarlung Tsangpo hits the gates with incredible force, but the engineering holds.
Inside the control center, every metric of pressure, flow, and structural stress is monitored. The command is given to open the gates and allow the water into the penstocks. The gates rise, and the water plummets into the dark tunnels.
Accelerated by gravity, the water hurtles toward the powerhouse at the bottom of the canyon. The water strikes the turbine blades, overcoming the inertia of the massive steel rotor. As RPMs increase, the world's largest generator comes to life.
The first cascade station successfully connects to the grid, generating clean energy.
As a run-of-the-river project, the water is immediately returned to the Yarlung Tsangpo. Chinese officials maintain the design minimizes long-term water storage.
Hydrologists constantly monitor the water quality and sediment levels. This is crucial, as the river's flow is a vital lifeline for downstream nations like India and Bangladesh. Efforts are also made to stabilize the canyon walls and restore vegetation disturbed by construction.
To prevent earthquake-induced landslides, heavy netting and rock bolts secure the surrounding cliffs. But the work is far from over. 4 more cascade stations must be built.
The entire process of drilling, pouring, and assembling is repeated down the Great Bend.
Each station harnesses a fraction of the river's 2,000-meter drop. Working in tandem, over 100,000 laborers and engineers push forward.
They battle through freezing Himalayan winters and intense monsoon seasons.
The supply lines must remain open, regardless of the brutal weather conditions.
Logistics ensure the massive workforce is fed and sheltered in this harsh environment.
Step by step, the ambitious vision mapped out by the planners becomes reality.
Advanced AI and drone technology are heavily utilized to monitor structural integrity. Advanced AI and drone technology are heavily utilized to monitor structural integrity. Digital twin technology ensures that any deviation from the blueprint is instantly detected.
Finally, the structure for the 5th cascade station nears completion.
The final turbines are installed, completing the mechanical heart of the mega project. The last electrical connections are made, tying the entire 60,000 megawatt system together. The Medog hydropower station stands as an engineering marvel of unprecedented scale.
The water, having passed through miles of tunnels and turbines, continues its journey.
Its energy is sent thousands of miles away, providing power to a rapidly modernizing grid.
The entire complex is operated centrally, generating triple the output of the Three Gorges Dam.
This immense power is a cornerstone of China's strategy for climate neutrality.
The facility is designed to run efficiently for decades to come.
However, nature remains unpredictable. Advanced seismic sensors monitor the active fault lines 24/7. Engineers remain vigilant against the threat of earthquakes and landslides.
Despite geopolitical tensions and environmental scrutiny, the project stands as a testament to human engineering.
A $1 trillion investment, built in the most unforgiving terrain on the planet.
The project has permanently transformed the Medog region. What was once isolated is now a hub of advanced energy production.
The sheer volume of water managed here is staggering.
The river continues its path toward India and Bangladesh, carrying the snowmelt of the Himalayas.
For the builders, Medog is hailed as the project of the century. A project that conquered the deepest canyon and the highest mountains.
The tools that carved through the earth now stand as monuments to the effort.
Powering the future, 300 billion kilowatt hours at a time.
This is the reality inside the Medog hydropower station. A titan of modern engineering, forever changing the flow of power in the modern world.